May 14th, 2025. Somewhere over the mountains of Kashmir. 4 French-built Dassault Rafales, among the most capable 4.5 generation fighters ever designed, were swatted from the sky by a weapon most Western analysts had dismissed as a theoretical threat. The Chinese-made PL-15 beyond visual range missile, fired from Pakistani J-10CE fighters, reached across 160 kilometers and killed with a precision that left no room for maneuver, no time for countermeasures, and no survivors. Within hours, the footage was everywhere. Beijing to Berlin. The talking heads spoke in grave tones about the rise of the Red Dragon, the brilliance of the J-10C, and the obsolescence of NATO's air-power doctrine. Defense analysts who had spent careers dismissing Chinese aviation technology scrambled to revise their assessments. Social media erupted with triumphalist commentary. The torch had passed. The era of Western air dominance was over, and the proof was burning in a Himalayan valley. To the casual observer, it seemed as though the United States and its allies had been caught sleeping. Their technological edge eroded by the relentless industrial march of the East, and in Washington, the Pentagon said, nothing. No press conferences, no carrier strike groups surging into the Indian Ocean, no panicked hearings on Capitol Hill, no blustering statements from 4-star generals, promising swift retaliation. The silence was deafening, and to the critics, it confirmed their worst suspicions. This was paralysis. This was the behavior of a declining empire that had finally met its match, that could no longer compete with the mass production capabilities of its rivals. But the critics were reading the wrong signals. The silence from the Pentagon was not the silence of fear, it was the silence of focus. Because while the world was busy crowning the PL-15 as the new king of the sky, the United States Air Force had been finalizing something in the Nevada desert that would render the entire debate obsolete. Welcome to ShadowWorks. Today we open the file on the Boeing F-47, America's first 6th-generation fighter, the machine designed to ensure that what happened over Kashmir never happens to an American pilot. A platform so advanced that the Pentagon awarded Boeing a $20 billion contract just to develop it, a jet whose true shape remains so classified that the Air Force deliberately distorted its own concept art to hide the design from Chinese intelligence analysts. This is the story of how the United States decided to skip a generation of warfare entirely, and what it means for every fighter jet currently in the sky. For 25 years, the F-22 Raptor held the title of the most dominant air superiority fighter ever built. Against high-frequency fire control radars, the X-band and Q-band systems used by enemy fighters and surface-to-air missiles to lock onto a target, the Raptor was a ghost. Its radar cross-section, reduced to roughly the size of a marble, made it effectively invisible to the sensors designed to kill it. But inside the classified briefings of the Air Force, the generals knew something the public did not. The Raptor had a weakness, and it was built into the laws of physics. Visual, animated diagram radar wavelengths interacting with aircraft surfaces, stealth. Despite what popular media suggests, is not a binary state. You are not simply invisible or visible. Stealth is a game of wavelengths, and different radars see different things. The F-22 was designed to defeat short wavelength radars, the kind that guide missiles. Against those, it excels. But as the wavelength of a radar beam increases, moving into the very high frequency or ultra-high frequency spectrum, the so-called meter wave band, something changes. The radar waves grow large enough to interact with the physical structures of the aircraft in a phenomenon known as resonance scattering. And the structures most vulnerable to this effect are the vertical stabilizers, the tail fins. To a meter wave radar, the tail fin of an F-22 or a J-20 or an Su-57 acts like an antenna. The wave hits the vertical surface, resonates along its length, and bounces back with a distinct, measurable echo. These low-frequency radars lack the precision to guide a weapon, but they don't need to. They serve a different purpose: detection. They are the tripwire. And China had invested billions building exactly these systems. Massive anti-stealth radar arrays positioned along its coastlines, designed to exploit this physics loophole. They couldn't lock onto an F-22, but they could see it coming. They could track its general location and vector interceptors like the J-20 Mighty Dragon into the area to find it. In a war for air dominance, being detected is the first step to being killed. The Pentagon studied this problem for years. They explored upgrading the F-22's radar-absorbing materials. They considered new coatings, new composites, but the physics was unforgiving. Cannot coat a tail fin in material thick enough to defeat a wavelength that is physically resonating with the structure itself. The material would have to be impossibly thick, impractically heavy, and still wouldn't solve the fundamental geometry. There was only one solution: remove the tails entirely. And that decision, elegant in its simplicity, terrifying in its engineering implications, is the foundation upon which the F-47 Banshee was built. On March 21, 2025, President Trump stood at the White House and announced that Boeing had won the engineering and manufacturing development contract for the Next Generation Air Dominance program. The aircraft would be designated the F-47. Honoring the legacy of the World War II P-47 Thunderbolt and the founding year of the United States Air Force, the contract was worth more than $20 billion. Boeing's defense division, hemorrhaging money from troubled programs like the KC-46 tanker and T-7 trainer, had staked its future on this competition against Lockheed Martin, and it had won. But the F-47 did not emerge from nothing. In a March 2025 disclosure that stunned the aviation community, DARPA revealed that both Boeing and Lockheed Martin had designed and built full-scale X-plane demonstrators under classified research contracts. Boeing's demonstrator first flew in 2019. Lockheed Martin's followed in 2022. Both aircraft logged several hundred hours of flight time, years of secret testing that validated key aerodynamic, propulsion, and stealth concepts before the contract was even awarded. Air Force Chief of Staff General David Alvin confirmed it publicly. For the past 5 years, the X-planes for this aircraft have been quietly laying the foundation for the F-47, flying hundreds of hours, testing cutting-edge concepts, and proving that we can push the envelope of technology with confidence. This means the F-47 program has been flying hardware in the real world since at least 2019. The public announcement was not the beginning. It was the moment the curtain was finally pulled back. But what the public received that day were 2 deliberately distorted artist renderings, showing only the nose and cockpit of the aircraft, shrouded in mist and shadow. The Air Force was not being coy. It was conducting counterintelligence. As one senior USAF official told reporters, the images don't accurately portray the aircraft. It should be taken with a large grain of salt. Boeing's artists deliberately distorted the features, and the Air Force made additional alterations. Chinese intelligence analysts, the official noted with apparent satisfaction, were welcome to spend as much time studying them as they liked. Good luck. What we do know, assembled from official statements, budget documents, and credible defense analysis, paints a picture of something unprecedented. The F-47 is widely assessed to be a Tailless design. A twin-engine blended wing-body configuration optimized not for one radar band but for all of them. The Air Force's own infographic rated its stealth level as Stealth Plus Plus, a full step beyond the F-22's. Stealth Plus and 2 steps beyond the F-35. This is the concept of broadband stealth, where the F-22 is invisible to the fire control radars of enemy fighters, but detectable by low-frequency search radars. The F-47 aims to be invisible across the entire electromagnetic spectrum, from the ultra-short waves of a missile seeker to the long, lazy waves of an early warning array. The engineering challenge behind this is staggering. A plane without a tail is naturally unstable. It wants to flip, tumble, depart, controlled flight. The B-2 Spirit proved a tailless design could work, but the B-2 is a subsonic bomber, a lumbering giant that doesn't pull Gs. The F-47 has to be supersonic, has to maneuver. Air Force Chief of Staff General David Alvin confirmed the F-47 will fly faster than Mach 2. The solution lies in a marriage of advanced thrust vectoring engines and flight control software operating at speeds beyond human perception. Split drag rudders, microscopic adjustments to the wing surfaces, thousands of corrections per second. The computer flies the aircraft, managing the inherent instability so the pilot can focus on the mission. Boeing's own history with tailless designs, particularly the classified bird of prey demonstrator from the 1990s, which proved stable enough to fly without computer assistance, gave them a head start no competitor could match. But the Banshee's stealth goes deeper than the absence of a tail. The engines, the beating heart of any fighter, present their own radar signature. On a conventional aircraft, the compressor blades of the engine are visible through the intake, creating a radar reflector. The F-47 almost certainly uses serpentine as duct intakes, twisting tunnels that ensure no direct line of sight to the engine face. A radar beam entering the intake bounces around the radar absorbent walls until it dissipates into heat, never returning to the sender. Consider what this means in practice. A radar beam from a J-20's AESA radar enters the intake of the F-47. It hits the first curve of the serpentine duct. A portion of the energy is absorbed by the radar absorbent material lining the walls. The remainder bounces deeper into the duct, hits the second curve, loses more energy. By the time what's left of the beam reaches the engine face, if it reaches the engine face at all, it's so attenuated that the return signal is below the noise floor of the J-20's receiver. The F-47 has swallowed the radar beam whole. The exhaust presents a similar challenge, and the solution is equally elegant. Engine nozzles are the hottest part of any aircraft, a glowing beacon to infrared search and track sensors that modern fighters increasingly rely on as a backup to radar. The F-47 is expected to use flat, trench-like exhaust nozzles positioned on the upper surface of the wing. This geometry serves two purposes. First, the flat nozzle diffuses the exhaust plume, spreading the heat over a wider area and reducing the peak temperature. Second, the upper surface positioning shields the nozzle from ground-based infrared sensors entirely from below. You see only the cool underside of the wing. Exhaust is further cooled by mixing channels that blend hot engine gas with cold atmospheric air before it exits. To an infrared search and track sensor, the Banshee is as cold as the empty sky surrounding it. And the engines themselves represent a generational leap, perhaps. The most significant propulsion advance since the introduction of the afterburner. The F-47 will use adaptive cycle power plants currently being developed under the Next Generation Adaptive Propulsion Program by General Electric and Pratt & Whitney. These engines can dynamically switch between fuel-efficient cruise modes and high-thrust combat modes in flight, something no operational fighter engine can do today. This gives the F-47 extraordinary range, a confirmed combat radius exceeding 1,000 nautical miles. That's Guam to the Taiwan Strait and back without a tanker, eliminating what has been the most critical vulnerability of American fighters in the Pacific. Now, let's be clear about what this means for the aircraft it's designed to face. The J-20 Mighty Dragon is a formidable machine. It is China's first true fifth-generation fighter and a genuine technological achievement. Its Delta Canard configuration gives it excellent supersonic performance and long-range capabilities that Western analysts consistently underestimated during its development. In terms of sensor fusion, the J-20 has closed much of the gap with the F-35, incorporating an AESA radar, distributed aperture, infrared sensors, and a sophisticated electronic warfare suite. But its design, like every fighter before the sixth generation, is built on compromises. It features large, all-moving canards near the nose and vertical stabilizers at the rear. These surfaces are necessary for the maneuverability that makes the J-20 lethal within visual range combat, and they provide the aerodynamic stability needed for its delta wing. But from a stealth perspective, they are geometric concessions to the low-frequency radar problem. The J-20 is stealthy from the front aspect, optimized against the specific high-frequency bands it's most likely to face in a head-on engagement. From the front, its radar cross-section is impressively small, but from the side, from below, against meter-wave radars, the very systems that China itself deploys along its own coastline, its signature grows considerably. The canards, when deflecting for flight control, create complex radar reflections. The vertical stabilizers resonate against long wavelengths exactly as the physics predicts. This is the paradox of fifth-generation stealth. The very features that make an aircraft maneuverable make it visible to certain sensors. The F-22 shares this limitation. So does the Su-57. Every tailed stealth fighter ever built has this vulnerability baked into its geometry. The F-47 has no bad angles. When a meter-wave radar beam hits the Banshee, it flows over the smooth, continuous curvature of the flying wing and continues into empty space. There is no vertical surface to resonate, no bounce back, no echo. To the enemy sensors, it is a hole in the sky. But here's the part the breathless headlines miss. China is not standing still. On the day after Christmas 2024, the world caught its first glimpse of something that sent shockwaves through every defense ministry on Earth. A Tailless Flying wing aircraft enormous, with 3 engines and a side-by-side cockpit, was photographed in the skies over Chengdu, China. The number 36 was stenciled on its forward fuselage. Military analysts tentatively named it the J-36. On the same day, a second Tailless prototype, smaller, twin-engined, with a cranked arrow wing, was spotted near Shenyang Aircraft Corporation's facilities in northeastern China. Analysts called it the J-50. China had not built one 6th-generation fighter. It had built 2, simultaneously, and both were already flying. The Pentagon's 2025 China Military Power Report formally acknowledged these programs. The assessment was blunt. China was no longer in the conceptual phase. These were active flight test programs backed by the country's top-tier aerospace industry. By late 2025, a third J-36 prototype with revised exhaust nozzles and redesigned air intakes was spotted, indicating aggressive iteration, the kind of rapid prototyping that usually takes Western programs years. The J-36, in particular, demands serious attention. Its Trigit tailless flying wing configuration, with a central engine potentially dedicated to supercruise and power. Generation suggests a platform optimized for extreme range, heavy payload, and potentially directed energy weapons. Its side-by-side cockpit implies a battle manager concept, where one crew member pilots while the other orchestrates electronic warfare and drone operations. Defense analysts believe it could carry the PL-17, an ultra-long-range air-to-air missile with a reported reach of 500 kilometers. And here's the uncomfortable truth that the original narrative of this story, America builds wonder weapon, China is helpless, conveniently ignores. The J-36 prototypes have been flying since December 2024. The F-47 won't make its first flight until 2028, by some assessments. The United States is 3 to 4 years behind China in 6th-generation prototyping. This is not a story of one-sided dominance. It is a story of a race. The outcome is far from certain. But the F-47 was not designed to win the race by being first. It was designed to win by being different. And the difference lies not in the airframe alone, but in what flies alongside it. For 100 years, the romantic image of aerial warfare has been the same. The lone pilot, strapped into a machine, relying on reflexes and physical endurance to survive. From the biplanes over the Somme to the F-15 Eagles over Iraq, the pilot was the sharp end of the spear. The F-47 kills this romanticism dead. Inside the cockpit of the Banshee, if the classified interior matches current NGAD doctrine, the pilot is no longer a dogfighter. They are something fundamentally different. A battle manager, a conductor of autonomous systems. The Air Force calls this role, conceptually, a quarterback for a wider kill chain. We call it the Sky Marshal. The F-47 does not fly alone. It is the centerpiece of what the Air Force calls a family of systems, the NGAD ecosystem. And the most revolutionary component of that ecosystem is the Collaborative Combat Aircraft, or CCA. In October and November 2025, the 2 CCA prototypes selected for the program made their first flights. The General Atomics YFQ-42A and the Anduril YFQ-44A, the first combat drones specifically designed to fly alongside 6th-generation fighters. They are stealthy, jet-powered, autonomous, and critically, they are attritable, built to be cheap enough to sacrifice. The Air Force plans to buy more than 1,000 of these drones. 2 for every F-47 and F-35A in the fleet. At a fraction of the cost of a manned fighter, they transform the economics of air combat. Here's how the tactical integration works. In a combat zone, say, the skies over the Taiwan Strait, the manned F-47 hangs back, loitering 50 to 100 miles behind the leading edge of the engagement. Operating in total electromagnetic silence, its radar is off, its radio is silent. To the enemy, it does not exist. Meanwhile, its CCAs push forward into contested airspace, acting as the eyes, ears, and expendable claws of the Sky Marshal. Imagine a J-20 pilot patrolling the airspace. His radar screen lights up with a contact. It looks like an American fighter. It moves like a fighter. It emits the electronic signature of a fighter. He commits, maneuvering to engage, activating his fire control radar to lock on. He fires a PL-15. The target explodes, but there is no victory. The J-20 has just destroyed a $20 million drone, a robotic decoy programmed to mimic the profile of a high-value target. And by firing, The J-20 pilot has done something catastrophic. He has revealed his exact position. His radar emissions have painted him as a beacon in the electromagnetic spectrum. The CCA that was destroyed was bait. It's hovering in the darkness 100 miles away. The Sky Marshal sees everything. The surviving drones triangulate the J-20's position. They feed the data back to the F-47 via a secure directional data link resistant to jamming. The pilot assesses the threat and authorizes a kill. But the Banshee doesn't fire its own weapons. It sends a command to a different CCA. A weapon-struck drone carrying AIM-260 Joint Advanced Tactical Missiles, flanking the J-20 from an unexpected angle. The AIM-260, the most classified air-to-air missile in the American arsenal, drops from the drone's internal bay. It has been in development since 2017, specifically designed to counter the PL-15 threat. Live-fire testing at Naval Air Weapons Station China Lake in February 2025 confirmed direct kills against maneuvering drone targets. The Air Force and Navy are requesting nearly $700 million in the 2026 budget just to begin production. Its range is classified but assessed to be roughly double that of the AMRAAM it replaces. The missile guides silently toward the J-20, receiving mid-course updates from the Banshee's network without activating its own seeker. Only in the final seconds does it go active, blasting the target with radar energy from point-blank range. The J-20 is destroyed by a missile fired by a robot it never saw, guided by a human it never detected based on data from a decoy it thought it had already killed. The pilot of the F-47 doesn't manually fly the drones. The human brain can't micromanage 5 or 6 aircraft simultaneously. Instead, the Banshee utilizes an AI-driven mission management interface. The pilot communicates intent, not instructions. Highlight a sector, sanitize this area. The AI calculates optimal flight paths, assigns roles, which drone jams, which draws fire, which flanks, and the swarm adapts to the changing battlefield in milliseconds. This solves the numbers problem. Critics have argued that China can build more J-20s than America can build F-47s. The Air Force plans to buy approximately 185 F-47s. But if each F-47 commands 2 or more CCAs, a squadron of 12 Banshees becomes a strike force of 36 or more aircraft. And the CCAs aren't limited to 2. Future increments could expand the swarm significantly. The Swarm Commander Doctrine ensures that the J-20 never faces a fair fight. It is outnumbered by platforms it can't distinguish from manned fighters, outflanked by weapons trucks it can't detect, and outsmarted by machine intelligence directed by human cunning. Consider the cognitive burden this places on the adversary. A J-20 pilot facing this system must solve an impossible puzzle in real time. Every contact on his screen could be a $20 million expendable drone or a $300 million manned fighter. The optimal response to each is completely different. Waste to place 215 on a drone, and you've spent $1 million missile on bait while revealing your position. Ignore a contact that turns out to be real, and you're dead. The swarm creates a fog of uncertainty so thick that the Chinese pilot is forced to hesitate, to second-guess every decision. In air combat, hesitation is death. Furthermore, the CCAs enable electronic hallucination attacks. A group of drones can fly in formations that trick enemy radar into interpreting them as a massive bomber strike package. The enemy air defense network lights up, expending missiles worth millions against phantom threats. Once the enemy magazines are exhausted, the real F-47 slips past the depleted defenses to strike command nodes. The economic asymmetry is devastating, and it runs in America's favor. The West is no longer firing expensive missiles at cheap targets. It is forcing the adversary to fire expensive missiles at cheap drones. The most dangerous pilot in the wars of tomorrow is the one who never pulls the trigger himself. The overarching shadow hanging over the Pacific theater is the Chinese long-range missile doctrine. The PL-15, with its dual-pulse motor and active electronically scanned array seeker, created a no-escape zone so vast that it effectively negated the tactical maneuverability of Western jets. Kashmir proved it wasn't theoretical. The terrifying calculus is simple. If you can't outrun the missile and you can't jam the missile, you die. For decades, the only defenses against incoming missiles were expendable countermeasures, flares to distract heat seekers, chaff to confuse radar, a finite supply. Once they're gone, the pilot is defenseless. Modern missiles like the Place 215 have countermeasure logic that can ignore these decoys. The other option, shooting a defensive missile at an incoming missile, burns through limited ammunition. An enemy fires 4 missiles, and you use 4 to defend, you're out of weapons and forced to retreat. This is the magazine depth problem. Now, this next section ventures into territory where we must be transparent about what is confirmed, what is projected, and what remains speculative. Directed energy weapons, high-energy lasers, have been in development for decades. The technology has matured significantly. The U.S. Navy has deployed the Helios laser system on destroyers. The Army has tested the Dasharad system for short-range air defense. Solid-state fiber lasers have become dramatically smaller and more powerful. Whether the F-47 will carry an integrated laser defensive system from day one is unconfirmed. But the trajectory of the technology, the size of the F-47's airframe, the power generation capacity of its adaptive cycle engines, and the stated goal of stealth plus survivability all point in this direction. Multiple defense analysts have speculated that the F-47's large airframe and powerful engines are specifically designed to support directed energy weapons. If the projections hold, here's what it means for the PL-15 threat. The concept is brutally elegant. As long as the engines are running, the weapon has ammunition, no reloads. No finite magazine. No counting remaining flares in a panic. The adaptive cycle engines act as flying generators, producing megawatts of electrical power needed to charge the laser's capacitors. A distributed aperture system, a network of infrared sensors around the aircraft, tracks the thermal bloom of an incoming missile's rocket motor with pixel-perfect accuracy. The fire control computer calculates the trajectory, slews the laser turret, and fires. The engagement happens at the speed of light. There is no travel time, no leading the target, no gravity drop, only instantaneous connection between the defender and the threat. Against a missile using an optical or infrared seeker, the laser can blind it. Coherent beam of 100 kilowatts focused directly into the seeker head is the equivalent of staring into the sun through a telescope. The sensitive optical sensors are instantly overwhelmed. The pixels on the sensor chip thermally overloaded and permanently fused. The missile goes blind, its guidance brain severing connection with reality. It reverts to its last known trajectory and flies harmlessly past the Banshee into empty sky. Against a missile using a radar seeker like the PL-15E, the approach is different. Missile at Mach 4 is already under immense thermal stress from air friction. Ceramic radome, the nose cone protecting the radar antenna, is operating at the limit of its thermal tolerance. Focused laser beam adds heat to that radome, creating thermal shock. Microfractures form, the structural integrity fails. Under the crushing pressure of hypersonic airflow, the weakened nose cone collapses. The missile disintegrates. The laser can retarget nearly instantly. Burn down one missile, swivel, burn down the next. It creates a defensive dome around the aircraft and its wingman. The saturation strategy, firing volleys of missiles to overwhelm defenses, breaks. Against a weapon that doesn't run out of ammunition. But we must be honest about the limitations. Atmospheric conditions, clouds, humidity, particulate matter, degrade laser performance. Power generation and thermal management remain engineering challenges at fighter aircraft scale. And adversaries are already developing hardened missile seekers and maneuvering warheads designed to complicate laser defense. This is not a silver bullet. It is an evolving capability that could fundamentally shift the balance if the engineering delivers on the physics. The year is 2030. The location is the Philippines. See the most contested airspace on Earth? At 45,000 feet. A flight of 4 Chengdu J-20 Mighty Dragons cuts through the thin air. They are armed with PL-15 missiles. They are supported by ground radars on artificial islands and early warning aircraft orbiting behind them. They are hunting their mission to sweep the sector and establish a no-fly zone for an encroaching American carrier strike group. Their pilots scan their displays, waiting for the electronic signature of F-35s, perhaps F-22s. They are ready for a fight, they understand, are not ready for what's actually coming. 200 kilometers away, 60,000 feet, the cold silence of the stratosphere, a single F-47 Banshee cruises in electromagnetic silence. Its radar is dark, its radio is mute. Its skin absorbs or deflects every frequency the enemy throws at it. It is not alone, spread across a wide invisible arc. CCAs shadow the Banshee, weapons trucks, jammers, sensor platforms, and expendable decoys. A distributed kill web, connected by directional data links, thinking and adapting in milliseconds. The Sky Marshal sits in a cockpit that feels more like a command center than a fighter. His heart rate is steady. He watches the 4 J-20s perfectly resolved on his panoramic display, their positions triangulated by passive infrared sensors on his drones, cross-referenced with satellite data and the thermal bloom of their engines against the cold background of the upper atmosphere. He has not emitted a single photon of radar energy. The engagement begins with a whisper. He taps a sector on his screen. To CCA drones, position 50 kilometers ahead, activate jamming suites, but not the brute force noise jamming of the past. These drones project ghost signals, false radar returns that mimic an F-35 flight. The Chinese flight lead sees contacts, then more, then 3 more. It's flickering, slippery, impossible to lock. His onboard systems try to discriminate real or electronic ghosts. He pushes his radar to higher power, trying to burn through the interference. This is exactly what the Banshee wants. By increasing power, the J-20 pilot has turned on a searchlight in a dark room. The Banshee's passive electronic support measures instantly triangulate his position to a margin of error measured in meters. The J-20 formation turns to engage the phantom signals, exposing their flanks. They are chasing ghosts drawn into a kill box constructed by the American AI. The Sky Marshal watches the geometry converge. He authorizes the shot. Fox 3. From the internal weapon bays of the CCA weapons trucks, and from the belly of the F-47 itself, AIM-260 missiles drop into the slipstream. Their rocket motors ignite, smokeless. They climb high, coasting on ballistic arcs, receiving silent mid-course guidance updates via the Banshee's data link. They never activate their own seekers. 100 kilometers. 80, 50. The J-20s fly on in silence. Their radar warning receivers are dark. There is no beeping tone. No alarm. Nothing. In the final seconds, the missiles go active. Their internal AESA seekers switch on, blasting the J-20s with targeting radar from point-blank range. Inside the Chinese cockpits, the silence shatters. Radar warning receivers scream. Pilots' eyes widen. There is no time to think. No time to maneuver. No time to deploy countermeasures. The no-escape zone has collapsed around them from a direction they weren't watching, at a range they didn't think possible from an enemy they couldn't detect. The first missile impacts the lead J-20 just behind the cockpit. The warhead detonates, shredding the fuselage and igniting the fuel tanks. The mighty Dragon disintegrates in a ball of orange fire and black smoke. A split second later, the second J-20 is struck in the engine section, spinning wildly out of control before the fuel tanks rupture. The surviving pilots panic. They dive for the deck, popping flares and chaff, screaming over the radio for information that no one can give them. They don't know where the fire came from. They don't know what they're facing. They don't know if the next contact on their screen is a drone, a missile, a phantom, or the Banshee itself. The swarm doesn't pause. The Sky Marshal assigns the fleeing targets to hunter-killer CCAs loitering below. They dive on the panicked J-20s, now bleeding energy, their pilots overwhelmed. In less than 3 minutes, the engagement is over. For fifth-generation fighters, billions of yuan in hardware, years of training are gone. And high above, the F-47 Banshee banks slowly toward home. It never fired a gun. It never pulled a high G-turn. It never appeared on an enemy radar screen. It was never in danger. It simply arrived, executed, and left. The J-20s died chasing ghosts. This simulation, and it is a simulation, a projection based on known capabilities and reasonable extrapolation, reveals the strategic logic behind the F-47 program. It is not a victory of better dogfighting. It is a victory of information superiority, of systems integration, of the decision to make the fight unfair before it begins. But let's resist the temptation of the clean narrative. The story of military aviation is littered with wonder weapons that didn't live up to the hype. The F-35 was supposed to be affordable. The Zumwalt-class destroyer was supposed to revolutionize naval warfare. Boeing's own track record on recent defense programs, the KC-46, the T-7, the Starliner, gives every reason for skepticism about whether it can deliver the F-47 on time and on budget. And China is not a passive adversary waiting to be overtaken. The J-36 is already flying. 3 prototypes by December 2025, with aggressive design iteration between each one. Its Trigit configuration, its tailless flying wing. Its potential for directed energy weapons. This is not the work of a country that is merely copying the F-22. This is a peer competitor, building its own vision of 6th-generation warfare, and by some measures building it faster. The Pentagon projects. Chinese 6th-generation fighters could be operational by 2035. Some analysts think it could be sooner, perhaps as early as 2031. The F-47 is expected to enter operational service in the early 2030s. The margins are razor-thin. What the F-47 represents is not an endpoint. It is a response in an ongoing technological arms race, one that will define the balance of power in the Indo-Pacific. For the next 50 years, the United States retains deep advantages in adaptive engine technology, combat networking, mature drone ecosystems, and operational experience with stealth platforms. China has advantages in speed of prototyping, industrial scale, and the political will to accept risk in development. The Banshee's true significance isn't that it can kill a J-20, though, in the scenario we've outlined. It almost certainly can. Its true significance is that it represents a philosophical shift in how the United States thinks about air power. Not a better night for the joust, but a system of systems, a manned command node, orchestrating autonomous platforms, directed energy defenses, and networked weapons across a contested battle space. The dogfight is dying. The era of the pilot who flies alone, fights alone, and wins alone is fading into history. What replaces it is colder, more calculated, and infinitely more lethal. A Sky Marshal commanding a swarm, a ghost that sees everything and is seen by nothing. A machine that turns the enemy's weapons into wasted metal. The strategic implications extend far beyond the Pacific. If the F-47 delivers on its promise, it doesn't just counter the J-20. It renders entire air defense architectures obsolete. The billions China has invested in anti-stealth radar arrays, optimized to detect tailed 5th-generation fighters, become sunk costs against a broadband stealth platform. The doctrine of saturation missile attacks breaks against a laser defense system that never runs out of ammunition. The numerical advantage of a larger air force dissolves when every manned fighter brings an autonomous swarm to the battle. But, and this is the critical caveat, all of this depends on execution. On Boeing delivering a program of this complexity on schedule, on the adaptive cycle engines performing as designed, on the AI systems managing drone swarms reliably under electronic attack, on the laser technology maturing from laboratory demonstration to combat-rated hardware. Every one of these represents a significant technical risk. And the history of American defense procurement is not kind to programs that bet simultaneously on multiple unproven technologies. The Air Force named it after the P-47 Thunderbolt, the workhorse that helped win air superiority over Europe in World War II. But the defense industry gave it a darker name, the Banshee. In folklore, a spirit whose scream heralds death, but who is rarely seen until it is too late. Whether the F-47 lives up to that name depends on whether Boeing can deliver, whether the technology matures, and whether the United States can sustain the political and economic will to fund a $300 million per aircraft program in a world of competing priorities. But one thing is certain, the contest for the sky has entered a new chapter. The machines being built to fight it look less like fighter jets and more like weapons from another century entirely. The dragon is not slain, but the ghost is in the air. If this story kept you watching, subscribe to Shadowworks. We cover the machines, the missions, and the secrets that governments tried to hide. Next time, we open the file on the weapon that started this entire chain of events, the Chinese PL-15 missile, and the Kashmir incident that changed everything. Hit the bell. The next briefing is classified.